Hey, so we're at 11:31 according to me. I think we'll get going, shall we? And we'll my little introduction will hopefully give opportunity for a few more people to come in. So first of all, thank you for attending today. My name's Paul Plester. I'm the Deputy Chair of the New Zealand RFID Pathfinders Group, and I have the pleasure to introduce this webinar. This passive sensor tag webinar is presented by SensThys in conjunction with the New Zealand RFID Pathfinder Group and with the help from GS1. The New Zealand RFID Pathfinder Group is the New Zealand RFID industry body, and we work closely with the GS1 New Zealand together and represent RFID knowledge to users and those interested in RFID, mainly within New Zealand, but quite often we go outside the bounds of that too. If you're interested in joining the RFID Pathfinder Group, please go to our webpage, which is rfid-pathfinder.org.nz. So let's talk a little bit about SensThys. SensThys' mission statement is to enable business decisions using wireless sensors and identification. And today we have the pleasure to have Joe Major and Neil Mitchell on the line, and specifically to present on passive sensor technology. And I'll pass over to you, Neil.
Okay, well, I'm going to make it really easy because I'm going to pass over to Joe.
Yeah,
okay, Joe then.
Initially.
So Neil runs sales and marketing within the company. My name is Joe Major. Yeah, I'll take care of you, Neil. Before we start, I think it's useful to sort of set the stage with why are we here and what do we find interesting and what do we find quite compelling about sensors and what do we find a bit something we want to caution people against. So we're going to tell you about how these tags are made and designed and how they function, but basically they're die vendors. The die vendors are all startups. They have sometimes quite a lot of funding. They're very active in marketing, and they're there to sell themselves. So they say it can be read by any reader and it can this and it can that. And the reality is much more complex. We really love those die guys. We have great relationships with them. We solve a lot of problems together and for them. But to give you a feeling for some of the odd things that you'll see in the sensor world, a moisture detector is extraordinarily sensitive. It can detect 5 microliters of water. Okay, so that's a tenth of a drop of water, and this thing, bang, we know that it's wet. But the water has to touch the tag, so it's totally blind to water that's a centimeter away from the tag. And like any RFID tag, if you get it too wet, it goes dead. So your sensor, your water sensor, it has to touch water. It's quite sensitive, but if it gets too much water, it dies. Strain sensors, we have people, great to see somebody who's doing fiberglass here. They're a load-bearing fiberglass member. They wanted to measure strain. Super excited. The tag works great. We show them how to put it into fiberglass and the tag disappears. And it turns out that in the fiberglass environment, the tag goes invisible because of the RF properties of fiberglass. So we help them figure that out. And now we have a strain tag that works in fiberglass. Another really funny example is we measure temperature all the time. It's a great thing to measure. Someone had a heating blanket underneath a part that was going through a chemical reaction. We had the tag in the part with the chemical reaction. And of course, the heater, it's got an electric current that goes through it, and it generates enough noise that the tag produces corrupt data from time to time. And if you don't know how to handle that, you might wonder why the temperature suddenly went to 12,000 degrees F. Those are all sort of the difference between the capability of these tags, which is something to admire and be excited about. And the reality is that these applications can be glorious. They can be super sophisticated. They can be very stunning in what they can provide you as information. But there's a whole series of material science problems and RF problems that need to be worked through to get to that glorious end. And that's where we live. And so with that, we'll go to the next slide. Yeah, so as corporate overview started in 2017, primarily in RFID. We have the vast majority of our funding is self-funded by the employees. We do have a couple of institutional investors, bless them. We've been growing quite quickly. It looks like this year we'll bump that number up quite a little bit, but a lot of that growth is starting to be driven by getting into large-scale manufacturing with sensors where we can provide information that people haven't ever seen before. And over to you, Neil.
Thanks, Joe. So a little bit of why we win and where we've seen success and why we've seen some success, just from kind of a high level before we get into details on the passive sensors. In terms of our infrastructure, we're a US company. We do the sales and marketing from the US. All the designs done in the US. But our manufacturing is all done out of Foxconn, which some of you probably are familiar with, is the largest contract manufacturer in the world. So if someone does ask us to produce 1,000 readers and ship 1,000 readers by next month or something, we can turn that on pretty quickly and do that. The team, we've got global experience throughout the world. There's public and private leadership within the company. So we have a very good set of skill set, very broad skill set, and we're also very, very technical. So there's a bunch of PhDs in the company, and we love talking tech, and that's why we've actually ended up being migrating to some of these passive sensor applications. We are very innovative. We've gone through 5 generations of readers in 5 years. We really do like to make sure our technology is the best it can be and very, very current. And that kind of attitude's led us on again through to this passive sensor space for a variety of reasons. Partly we were reached out to by some of the semiconductor companies, partly we saw a need for that type of application, and we had the RFID experience as well. So bit on the partners. So on the top left there, you can see the fact that, again, Foxconn is our manufacturing partner, and MTI, who is part of Foxconn, does help us there too. In terms of some of the other partners we have Jos here from Time 7, where you can see the list of partners we're involved with: Avery, Denison, HID, Dentive, Axon, and so you can see some of the IC guys there that we work with. Of course, we work with Paul. Hi, Paul, on the Zetec side.
Yeah, Paul.
And we have partners in Australia, in Europe, and elsewhere as well. And we also work with a bunch of organizations that are relevant to some of the verticals that we're involved in. And there's a lot of verticals we are involved in. And we were on another meeting this morning, and I was asked, well, which markets are you in? And the only thing I could definitively say is one market we're not in, and we don't focus on, I should say, is retail. Everything else is fair game for us. But anyway, we are working quite closely with a number of organizations and companies that are involved in composites, fiberglass, carbon fiber, etc. And we'll go through some of that during the call today. And we're also involved in a lot of medical stuff and healthcare stuff as well. So we're involved in some of those organizations too.
So the problem's kind of an interesting one. Sensing is, in a lot of manufacturing settings, is both hard and expensive. We have a guy from the fiberglass industry on the call, maybe more. And in that industry, there's really interesting chemical reactions that are going on that generally the manufacturing world is completely blind to. It's very difficult to understand the quality of an epoxy resin statistically. It's very difficult to know that epoxy is reached everywhere in a mold, or when the epoxy actually hits the solid state of cure. And we help make those things. That's a problem. Not being able to see stuff as a problem. And we list kind of the reasons, and you can read as fast as I can talk. We list some of the reasons there that this is hard. It's also quite expensive. Quite often we're replacing sensors that are $100,000 or $250,000, and a reader and some tags that are frankly disposable can give the same equivalent information. And it's very transformative there. Neil?
So, yeah, if you kind of paint the picture of an ideal sensor, what would it look like? And, a bunch of us here, I'm sure, are familiar with RFID, maybe some are not, but from an RFID world, we look at this thing and we don't understand what it is. But if you actually kind of say, well, okay, what's an ideal sensor that will go into some of these solutions? You'd probably list things like, well, I don't want wires going everywhere. I don't want batteries because they run out and they need to be replaced and they're bulky. I want something very small. Ideally, I would like something so small it's ultra thin and I can place it within layers of different materials. I don't want to have to maintain it. Goes back to the battery comment earlier. I want to be able to detect it remotely, wirelessly. I want it to be automated, and I want it to be really economic. I want it to be relatively inexpensive. I want these tags to be, these sensors to be the opposite of the $1,000 statement that Joe just made. I want it to be, a few bucks perhaps. And that's where we are. This is where we are with these types of sensors. And you can see an example of one in the image there.
We're going to talk about supply chain, and you all may think, why in the world, they're pitching us sensors. Why do we have to think about the supply chain? And the reason, it'll be evident when we talk you through it, but the supply chain is really good here at making low-cost RFID tags. The supply chain isn't so good here if you say the medium I'm in is a high dielectric constant with a loss tangent of X. And that changes to this dielectric constant and that loss tangent during the process. And I need to be able to operate in that environment. Those kind of statements are outside of what the industry normally does. And when we walk you through this, we'll give you a feeling for how do those problems come up and how do we help you solve them? So over to you, Neil.
So let's talk through what one of these sensors looks like and what's actually constructed within them. And so the first thing to talk about is there's a semiconductor component on there. The IC or the die, there's many different names for it, but this little chip that's sitting there in the middle of this RFID structure. And it's part of the intelligence that make up this end solution. There's a lot of smarts that go into the chip, but there's also smarts that go into how this thing is designed and put together. Effectively, there's multiple antennas attached to this thing in reality. But as you can see there, the chip is really, really small. We'll hold one up here so you can kind of see it. This is actually, obviously you won't be able to see the chip in it because it's way, way too small. But this is basically one of the sensors that we're talking about. Joe?
Yeah, I'm looking at my numbers and thinking, this is mine. So the next step is a layer of plastic and an antenna is married to that die. These die are a little bit more complex. They often have multiple antennas or devices that connect to them. This is really where problems can start to arise because the sensor has to function at the same time that you can read the tag. And we place these labels into a wide variety of settings that are well outside of what most of the inlay manufacturers know or love. And so to be able to talk to them about what the full stack is and the materials and model that out, it's much more akin to it design an antenna in a foreign material than it is a free space antenna. Neil?
Yeah, and just one additional comment. I mean, effectively, you're seeing an aluminum antenna there. That's actually doing, normally in RFID, it's doing two things. It's basically a receiving antenna. It's actually producing a potential difference across it from RF. There's also a signal coming in, so it's actually translating that signal. Then the chip's doing its thing, and it's modulating a signal back. So well, that's three things, really. With these passive sensors, it's even more complicated than that because these sensors are now also involved in actually providing information to the sensor inside of it. So it's even more complex than that. And then the next step after you see the aluminum antenna and that is to actually put it into a label and or at least into a protective structure or a something you actually would like to apply into your system. And often, we're talking about something where you want printing on it. You may want a barcode on it. And you would probably want it a few layers. So, do you want it white? Do you want it, what kind of structure do you want it on? Do you want it rolled? Do you want it sheets? Do you want it, which way do you want it to unwind? I mean, there's a whole complicated array of questions that come with how these things are provided. We can certainly help you with that. It's not rocket science, I would like to say, but there's just a hell of a lot of details, and then we can certainly help you through that. But in addition to the label you see there on the top left, there's other different formats these tags can come in, these sensors can come in. Another flavor is one where it's designed more for going onto metals. And you can see from the look of this one, it's a little bit thicker. It's got some other additional material involved in it. There's different flavors of that. If you apply that onto a metal in, say, a vehicle, maybe now we want to get moisture wicked to it or transported to it, so this RFID sensor can do its thing. So now you're talking about attaching a wick tail in order to draw water towards it. Again, that's something we've been involved in and defining what that wick looks like. And at the very bottom there, you've got actually an example of a ceramic sensor. And that would usually go into something, obviously, where there's a need to have something very protected, because either it's in extreme heat or it's by something where it's going to get bashed around a lot and physically abused, so it needs to be in a stronger package. And so we sometimes see these RFID tags and these sensor tags being used in that kind of form. And again, we can work with partners to kind of advise them which way to go. So
one comment before, can you go back one slide? Yeah. Although Neil didn't mention it here, generally this is where the sensor does its own thing and reports data. The RFID reports its EPC sort of at the same time. But in a typical manufacturing setting, the information that's placed onto these parts is one of the things that ties it to the manufacturing world. And so as an example, a technician places this into an injection mold, barcode scans it, that associates the barcode with a location on the part. And so when the sensor is read, it chokes up its EPC, it gives it sensor data, and all of that is now associated with a specific part in manufacturing. But making these things integrate nicely into the manufacturing flow is sort of a design for engineering problem. And then there's an aspect of this of making the tags easy to use in volume in a production setting. Sorry, Neil.
Sure. So basically now we have all of this capability built into these passive sensors. So they're now able to tell us a number of different things. There's a unique ID that Joe was just talking about. So that's basically going to be absolutely guaranteed to be 100% unique in every single RFID tag ever produced. And when you read these things, when you interrogate them, they're usually interrogated within, let's say, within 10 feet. RFID can actually work further than that. We can get into more details on read distances and stuff maybe another day. But basically, you also now know where something is because you know which antenna is actually interrogating that particular RFID sensor. And as these things are now reporting temperature, they can report moisture, relative humidity, strain. So I literally have, sometimes we do a demonstration and I've got a strain tag attached to a ruler so I can actually measure the amount of strain going on. Index refraction, capacitance, pressure. So you start building up a picture of this environment, the condition that something's in, the location, and when that was read, where it is, what condition. So all of a sudden you've got a whole bunch of information provided just by these sensors. And these are inexpensive sensors, but the lifetime is still extensive. It's 50 years, just like most passive RFID tags. And there's also something else which is pretty unique about these sensors, which is surprising to people who come in from outside of RFID. And that is, okay, these things are wireless, but we can actually read 100 or 1,000 of them with a single reader, single antenna, or a couple of antennas if you wanted to. But normally in the sensing world, you have one wire going to one sensor and you've got to plug it in and you can only do 4 sensors and then you run out of ports and you need to buy another piece of kit for $50,000 and you repeat. We don't need to do that. Basically, you can put as many of these things in and you can read 100 or 1,000 of them, 10,000 of them.
Yeah. So it's important that we understand with our customers, or help our customers understand how to think about this capability. And so we've worked with Assign in particular very closely to help customers understand where things are and what is required to go from where that is into a full application. So Axon has been around for much longer. They do have in production, which means, you know, we can get you tags and they're reasonably priced and they work. Temperature, moisture, and index sensors. If the inlay of one of those doesn't work in the application, which happens fairly often, then basically we have to go back to stage number 4 and make a proto label and then make the samples and get into production. Assign, it's a younger company, very, very, very capable company, a lot of fun to play with, much broader. The physics of the device gives them more opportunities to sense different things. So you can read that list. Temperature tags are in pretty good shape. You can buy them. They're entering prime time. Anything that says beta means that they've made this in a large enough piece of a wafer at high enough volumes that they understand their statistics and they're ready to go into production. Commercial die means that they've not grown, but they've processed a full wafer of these things and it's lots and lots of them coming out. To go from beta or commercial into production, assuming that the no existing label works, means you go to an inlay designer. We work with them on the physics of the local situation. They put together a tag, we test it. If it works, we put it in your environment and verify that it works, and then take that into production. That process is not tremendously expensive. It's 3 to 6 months long. So basically, with the exception of light, where they haven't really pushed very hard, all of the capabilities there are 3 to 6 months away from being prime time in your environment. One of the reasons we wanted to talk about the partnership in the supply chain or that ecosystem is quite often we have to work through the ecosystem. So we're calling up Identiv or Tagios or whoever's the guy on call and working out with their antenna guys what they need to do to make this work and testing it and then getting out to the customer. And the strain example I gave you was, again, directly observed in the field and was fixed by Tagios, was very kind, good, smart engineers. They fixed that problem within about a month. Okay, next, Neil. Yeah, so on the software side, Neil's going to speak about PhiSense. That's the sensor program that we use for sensors, but there's a series of applications that come with our hardware that you buy. So ProSense is a broad-featured reader management tool. PhiSense is really dedicated to sensors. It can do all kinds of brilliant things, like it can actually figure out whose sensor it is and what kind of sensor it is and do all the calibration and for it. It's great. A command center probably doesn't interest anybody here. That's if you have 75 readers in a facility and you want to manage them from a single point. AutoSense is a very nice automated reader management. And so you basically tell the reader what to do when it wakes up and goes to work. I'm not going to spend a whole lot of time on performance or the SDKs. You can always call us about those things. We've always taken security very seriously. And we're not going to talk about it, but it's pretty easy to show that these readers, we think, are the most secure readers that you can buy on the planet. And I'll turn it over to Neil next to talk about SensThys.
So, as Joe said, SensThys is the tool. Really focus on reading these passive sensors today. And the nice thing about the tool is we've been through multiple iterations with it now with customers, as we've been kind of pushed by different customers to increase capabilities and functionality. We're now at the point where the single application, it's a Windows application, you can download it from our website today. It supports all the different dye vendors that we've been discussing here, Axon, Assign. It will decode all the different tag types that we've been discussing here, strain, temperature, moisture. So it has that capability built into it. And one of the really nice things about it, and you'll see this in the next couple of slides and videos, we've been pushed to provide some real-time reporting capability in the software for our customers to read and access these sensors. What do I mean by that? So basically, we now have a tool where you can say, I want to read all of these sensors, 10 sensors, 20 sensors, whatever it happens to be. I want to read them every 15 seconds, 20 seconds, every 2 minutes, every hour, every day, however frequently you want. And I want you to log for me multiple parameters. So we can log two different parameters in parallel. Temperature is usually one, and then there's usually another one, such as strain or moisture. And we can plot those on a chart in real time on your computer, so you can actually see what's going on in the material that you're currently looking at and trying to measure. In addition to that, we save that data as well, so you can later go back and examine that particular sets of tests that you did, or that particular mold that you were forming. So that's all built in. You can download that today.
So, Neil, we're a little long, so we should go quicker if we can. Everybody on this call probably recognizes this. This is a reader hooked up some antennas. It's looking at a bunch of tags. The readers can multitask, so they can do an inventory on one antenna when they do sensing of something on another and sensing of something on another. They can do all of those things on all the antenna ports. So I think next.
So, yeah, so what we're going to do now, so these are literally just 1 minute videos each, and just got a couple of them. So this one here is SensThys in operation, and we're actually going to run it and show you what happens as we measure water and heat. So at the top we have in orange moisture reading, and then the blues temperature. So every 15 seconds in this case we're reading. And then something's happened there, that there's been moisture detected. And this tool basically resizes the chart for you. So now we're starting to see a very slow increase in that moisture level, and then all of a sudden it's going down again. And something's happened to the temperature. It's gone, you see the blue line there, it's gone from 20 centigrade to 40 odd centigrade there. So you can see there what's happened. 1 drop of water, cold water, 1 drop of hot water landed on these things. They were drying out. You can see the temperature of that water. You can see when it happened. So all of a sudden, you know immediately when looking at this data, there were 2 leaks. They were both transitory. One was a cold water drop, one was a hot water drop. You know that all just from that information already. So this is another view of it. This is one we kind of captured earlier and kind of just annotated to make it a little bit easier to see. We'll give you access to this presentation material so you can see it afterwards. I won't go through the whole thing because it's basically what you just saw. But you can see here the dry level, the wet level. You can see the difference here. You can see the big spike in temperature here. That's pretty much what you just saw. And on the right-hand side here, we have the temperature in centigrade. And then on the left side, there's basically a special code value, which is representative of the other thing that you're measuring. And then one more we'll show here, which is the strain. So here I'm basically taking one of the strain tags, I put it on the business card, and I'm bending the business card. I'm going to bend it in 2 different dimensions and at 2 different extremes. And one comment on that particular video, that was actually done with an uncalibrated early prototype. So what you'll see is also those things can be made more extreme. So you'll see that a little bit better in future, or you will now.
One comment about the strain tag, we were having a lot of fun with that strain tag. Of course, that strain tag, when you put it into its application, fails. And it has to be adapted to work in the real world. Okay, we're going to show you, this will explain itself. I'll talk as it goes. Hit it, Neil. So there's a sensor in a simple plastic cup. The reader here, I don't know how far away it is. It's probably 3 meters away. There's the baseline. We're going to add epoxy and directly measure how exothermic it is, and directly measure when it flips from the liquid state of cure to the solid state of cure. And as this, as the time goes along, the point where it flips to solid becomes very clear. It's also clear, and we'll talk about it in a second, that the cure is proceeding as the orange line moves up. So if we go to the next slide, yeah, you can skip that. So this is actually inside of a mold. And so we're looking through a whole bunch of different things on this particular one. And a little bit different sensor, different chemistry. So you see a little bit different response, but you can see the epoxy enters very clearly. So if you want to know, has epoxy reached a point, you know it. The chemistry of epoxy was first really mapped with interdigitated capacitance sensors in the 60s and 70s. And this is in effect mimicking that. And instead of having wires and a lot of bizarre stuff, it does it at a very low cost point. But it actually tracks the flipping of this from, if you've worked with epoxies, they're sort of like honey, real thick and viscous. Then all of a sudden they kind of get hard. That's that part where it gets hard, that's flipping into the solid state phase of cure. We also track the max temp and when the max temp occurs. If we're doing that for epoxies, just looking at raw chemistries, we can actually see differences between various epoxies, and we can detect incorrect epoxy mix ratios. Finally, as that orange trace goes up, you can estimate how far along it is in its cure process. That's a really neat thing to say to somebody. What's the temperature inside my mold and how cured am I? And the beauty of this, of course, we can't see this tag when this is going on. It's, I don't know how many layers that we're looking through to get to it. But you can say, and bring under statistical control, did the resin arrive and at the right time? Did the phase change occur at the right time? Are all of these things statistically in a normal distribution? And suddenly the world of Six Sigma and the world of, I know how to control my manufacturing and get better yields, better cycle times, better economies, better quality, is opened up in a lot of large scale manufacturing where you couldn't see inside before.
Yeah,
Next.
10 of these or 20 of these into a structure, which is, you know, some composite structure during curing. You know if there's a void in some area, some areas yet to cure, hasn't gone to TG point. So you know when to demold it, when not to, and how much resin you got to get put in. That's just not been before.
Yeah, a really interesting. Thanks, Neil. A really interesting side experiment that we stumbled upon was we put a high number of tags in the path of epoxy flow, so we did it so that we could map the velocity of the epoxy as it moved along in the particular. That wasn't an injection mold. There's another manufacturing technique. But what was really interesting about it is epoxies and fiberglass are very poor conductors of heat. And we would find these wild thermal gradients. And so the thermal gradients, if a thermal gradient exists when the part cures, you bake strain into the part. And in fact, strain sensors can be put in there and actually show that high thermal gradients correspond with high residual stress. Next.
So we're going to whiz through some of these, but we just wanted to give you a little taste of some of the varied applications that we're seeing with some of these passive sensors. One of them is smart building materials, and we've worked, for example, with a company that's basically producing the very specialized roofing materials that go into commercial and industrial buildings. And we developed, you can see a prototype of the cart there. We developed this cart that basically runs around the roof. It's got an RFID reader, the antenna in it. And basically, these passive sensors are actually buried inside of these layers of this gypsum material. And we're able to just basically take this cart, move it over the roof, and this particular reader has GPS built into it. So we basically end up with a map. It's a moisture map of the building, of the roof. And in this testing that we did in a company in the south here in the States, we actually found 3 leaks in their roof they didn't even know about.
Okay, so in an effort to go faster, machinery, you want to make sure it doesn't get too hot. And if it's getting too hot, you want to turn it off before it does any damage. There's a lot of different applications for that. You can imagine that these things can look at a lot of different tools in an area all at the same time. And so it's a pretty neat application. Next.
Good use for ceramic tags. One that we kind of touched on before, so I won't go through all the gory details here, but is automotive manufacturing, where it's a huge cost if a car goes out with a leak in it, and if your name's Audi or Ford, it doesn't really matter. If you manage to kind of anger a customer, you're going to really, they won't come back to you. So it's not just several $1,000s of repair, which it is. It's that reputation loss as well. Anyway, so basically we're been involved with some companies here that are doing kind of the high pressure testing, water testing of the vehicle during the manufacturing, on the manufacturing line, on the production line. So basically we've developed some software, some iOS and Android software that basically does a before and after comparison. So they can test these tags that are being placed into the vehicle, some with wicks, some without. And it's tested in red before it goes through the spraying machines that spray the vehicles, comes out the other end, you retest it, you get a red or a green light depending on if there's water there. Simple as that.
Yeah, so in pharmaceuticals, there's lots of applications. I think at this point, though, it probably serves us well to open it up for questions because we're running a little bit late. Let's skip this one. I'll briefly go through this. We have not had a successful, I shouldn't say that. We have had one customer that with very little coaching got up and running and reading some good stuff. And we are proud to say they are Kiwis. So, but generally speaking, we've only been able to get things running and running smoothly when we go visit. And that's typically because it is a ton of material science to kind of weed through. what material do you have? What are you trying to see? You know, the environment can corrupt sensor data, and we can help that minimize the corruption. We also have methods of finding it and getting it out so that even fairly corrupt data can be made usable. It is non-trivial to optimize a reader for sensors. You know, if you read an RFID tag, you declare victory. With a sensor tag, if it has too little power, if it has too much power, if it's too close to noise, all of those things give you crap. And it's sometimes fairly difficult to figure that out. Neil showed an application for leak detection. That leak detection has a 29-page application note, and it covers all kinds of crazy topics to try and help people. We already preached about the die and the inlay, and you know, we want to go ahead.
I just say we should say that we've done a lot of software that manages a lot of that, in addition to having to bring our own expertise to bear on that.
That's true, and a lot of times the software that we do makes the Kiwis that got up and running basically with not too much support. They benefited a lot from us struggling through a lot of problems in that area. So that's all we got. We'd be happy to answer questions and help you understand anything that you're concerned about or curious about.
I'll get us out of the blocks, Paul. Fellas, have you given any consideration into eco-friendliness when these tags get put into landfill, for argument's sake, after they've expired? I'm thinking things like eco-friendly tags, which are coming out now without sensors in them. What's the impact, if any, of putting sensors into landfill?
So
I think one thing we do is we're not putting batteries into landfill.
Yeah, that's a great starting point, actually. Yeah, so honestly, we have. It's kind of funny. I'm going to give a little bit of a blurb from the company and on our packaging and our shipping. We work sort of relentlessly at increasing packing density and reducing packaging materials, both to minimize shipping costs, minimize waste, and minimize sort of the global warming aspect of us shipping stuff around. We've spent a lot of time there to be the best citizens we can. These tags typically are fairly standard tags. A lot of them are embedded with the life of the product. And I'm not trying to obviate the need to think about it, but a lot of these things, if we put a tag in the rotor blade of a helicopter, it'll be recycled with the helicopter blade. The ones that are not that are not long-lived, they are standard things, and we should probably think about can we put them on something? I don't know if PPT is particularly environmentally friendly, but if it's not, we could certainly put it on a material that is. And it's a good, fair question, and we're doing the best we can on shipping and packaging. On tags, we probably need to think more, huh? Next question.
I'd just like to add that I was involved in the first SensThys implementation here in New Zealand, and while I'm an RFID guy and have been for a while, without the SensThys hardware, I struggled to read sensor tags. Once I got the SensThys hardware, it became very, very simple and very intuitive. And, even the handheld reader where there's a drop-down menu to select the type of tag that you're trying to read and therefore go to the right memory location, was really good. And while I'm an RFID guy, Drew, who's on the call here, is not an RFID guy. He's a composite guy, and he's been using the hardware to read his tags and his compositions quite successfully, and been all sorts of interesting experiments with it.
Yeah, I have to say that, particularly with large-scale things where you've never seen inside a manufacturing process, you get these sensors working and calibrated and they're functional, and all of a sudden you see these things that have only been in textbooks, and we get really nice comments from customers. And this interaction, we had a couple of them where I saw it. So that does feel good. Other questions?
Yeah, Josh Coonan here from Time 7, and thanks, Joe and Neil, for the presentation. Extremely interesting and thought-provoking for the myriad of applications that could be used. And I think you gave us a good impression in the beginning of what the maturity of the technology is and some of the challenges that we need to address. In terms of low-hanging fruit, do you see some particular sensing activities that are pretty easy to deploy? And secondly, you've got some experience of down in New Zealand. Many of our customers probably can't afford the cost of you getting on a plane down here the whole time. Any sorts of applications that we could be looking for in terms of also how can we best remotely support them or get you guys engaged?
Yeah. So actually, you asked several questions. Let's see if I can remember them first, which is a test of my mental acuity, and then answer them. The first is low-hanging fruit. And first, before I touch on that, I appreciate the fact that you said, look, talking about the maturity and what needed to happen for these things actually to be brilliant, which is non-trivial, I think sets the right expectation. These things can give absolutely stunning results at a cost point that makes other sensors just irrelevant. I really believe that we're investing our time there. That said, these things do take a bit of time, and it's not a lot. The NRE required to get a really great sensor solution going is typically far, far less than the cost of these more expensive sensors. So there is work there. The second question is there low-hanging fruit? And that's a harder one. Honestly, I don't have a great answer for you there. The truth is, where we've had the best success is we get a very smart technical guy from a particular industry that looks at this, and we have a fun conversation, and they really champion it. And we here have a wonderful relationship where we're on the phone, we're looking at results, we're chatting all the time, but they really do help us grind through in their environment. Once we do that, then the implementations are pretty fast. And I do want to give respect to the Kiwi folks that got this up and running so quickly, but I want to give a lot of credit to someone who's on our technical advisor of the board, because he was one of the technical people that, his name's Samuel Oosterman. He gave us a ton of support and worked through together with us a lot of details about what is an epoxy. So we do great in large scale stuff. So there's enough dollars flowing through and a manufacturing line that improving efficiencies by 10% or reducing scrap by 20% is a big game changer. And then if it's new to us, a technical champion on the inside makes that go. That said, these are fair because there are big things and big manufacturing environments. It does take a while to get the design win. You do get baked in, do a nice revenue flow, but it does take a while. And I can't remember the last part of your question.
Maybe I can ask the question a different way. In terms of low-hanging fruit, what's the sensing parameters that are pretty reliable to get a good result? So temperature, humidity, strain.
So the ones that are most mature and we have the most experience with, which kind of translates into we know what to tell to the guys that make inlays, and we've had enough experience with them that when they send us bullshit data, we can find it and fix it, which is sometimes mathematically non-trivial. Our temperature for both firms, moisture and dielectric constant coming out of the Axon world, the strain sensor, strain with temperature is a great sensor from a sign. Lovely, lovely sensor. The relative humidity sensor, which is measuring moisture levels and temperature simultaneously. And we're actually taking those. We read a couple of calibration fields, and we take the data off and turn a moisture level with the temperature into it. The relative humidity in that room is 87%, and it's pretty damn accurate. Those are all very, I don't want to say that there's not technical problems implementing one of them, because you work through them, but those are, we had have sample tags out today. We can talk about inlays coherently today. The last thing you said is, we're down in New Zealand, flights are expensive. I don't know exactly how to answer that. When we come out and we spend a couple days doing an install, the people that are around us, we just did one in Rhode Island, those people now know what to do. And I think if Paul finds a customer that really has something unusual that needs us, and he brings us down, and he has a couple of his folks, or I don't know if you guys are buds and you bring somebody over from Time 7, but if somebody hung out with us for a couple days, that is pretty good training, because you start to see there's a calibration process for these tags, and there's a calibration process for the reader and the antenna. And if you don't do it, it doesn't work. But once you've gone through it and you kind of understand why, and you understand that PhiSense has all of the tools already built into it, you just need to know what buttons to push in what order. Then it goes pretty smoothly on the second ones. I think, actually, I was just talking to a customer in Houston, and it was funny because he said, I know what to tell you and what to ask you if I have a problem. If you don't do that, and we do have people that they'll hear a spiel, they'll see one of Neil's videos, they'll buy a tag, they'll buy a reader, and they're totally frustrated because, it doesn't work. And so we do everything we can to try and get in front of that. But a visit, whether it's here or there, a couple-day visit with people gives them a tool set to really do pretty good work going forward.
That's an opportunity for Paul and I to work on to find a reason for you to come down and do that training familiarization.
Sure.
Okay then, guys. Well, I think if there's no more questions, we'll get back to our day's work.
Okay.
Thank you very much, Neil and Joe. We really enjoyed the session. It was informative, and you really got through it, and you showed us lots of interesting information. For the attendees, please come back to the members of the RFID Pathfinder, probably myself principally, but the others that come talk to them, and we can explore and qualify your requirements and talk you through a bit more of the nitty-gritty detail. But we have delivered a site here in New Zealand. We are confident that the SensThys solution is the best on the market, and we'll get you up and running and get you going immediately. And then we can actually start doing some clever stuff. So thank you very much, everybody, today. And thanks again, Neil and Joe, and for the Pathfinder Group and GS1 for hosting the session. Thanks, everybody.
Bye-bye. Thanks so much.
Have a good day.